Hey everyone, and welcome. Today, we're going to dive into a concept that is, absolutely fundamental to Python, loops. This is where the real magic happens, where you stop doing repetitive work yourself and start telling the computer how to work smarter, not harder.
I mean, you know that feeling, right? Doing the same task, saying the same thing, again and again and again. It's exhausting in real life, and trust me, it's just as bad when you're writing code. Well, this is exactly why the programming world came up with a golden rule, a core philosophy you'll hear everywhere. Don't repeat yourself. We just call it the drive principle. The whole point is to write code that's efficient and easy to manage, and copying and pasting code is, well, it's the opposite of that.
So how do we actually do that? How do we stay DRY? The answer is loops. A loop, which you'll also hear called an iteration, is basically a command you give Python. You're saying, hey, see this chunk of code? I need you to run it over and over again until I tell you to stop. It's the engine of automation in your code. Okay, so right off the bat, you've got two main tools in your toolbox for this. You've got for loops, which are your precision instruments. You use these when you know exactly how many times you need to do something. 5 times, 10 times, once for every item in a list. Then you have while loops. Think of these more like a sensor. They keep doing something as long as a certain condition is true. Let's dig into the for loop first. All right, let's grab our first tool, the for loop. Just like the subtitle says, this is your precision tool. You pull this out when you know the exact number of repetitions you need. So the job of a for loop is super straightforward. Run a block of code a very specific number of times. No more, no less. If you need to print hello exactly 10 times, or process every single file in a folder, the for loop is going to be your go-to. Now, a for loop rarely works alone. It's got this trusty sidekick called the range function. What range does is simple but powerful. It just generates a sequence of numbers. And that sequence is what tells the for loop precisely how many times it needs to run. And range is way more flexible than you might think. Just look at this. If you give it one number, like range 5, it starts from 0 and gives you 5 numbers total. 0, 1, 2, 3, 4. Want to start somewhere else? No problem. Range 1, 5 starts at 1 and goes up to but not including 5. You can even tell it what step to take. Range 1, 10, 2 counts by 2s. And yeah, you can even count backwards by using a negative step. It gives you incredible control. Okay, so what does this look like in actual code? Check this out. The line for I in range of 5 basically says, for every number that range of 5 gives me, I want you to do the following. Since range of 5 gives us 0, 1, 2, 3, and 4, the loop runs 5 times, printing hello each time. Simple, clean, and perfectly predictable. All right, tool number 2, the while loop. This is your sensor. It's the tool you reach for when you don't know how many times you need to repeat something. Right? This is the key question. What if you need to keep a game running until the player's health drops to 0? Or you need to keep asking a user for their password until they get it right? You have no idea if that's going to take 1 try or 50. And that's where the while loop is the absolute hero. It doesn't use a counter. Instead, it runs based on a condition. It's like a guard at a gate. Before each repetition, it asks one question. Is this condition still true? If the answer is yes, it runs the code. The very instant that condition becomes false, the loop stops. Let's look at a classic example. We start a variable num at 1. The while loop checks, is num less than or equal to 5? Yes, 1 is. So it prints the number 1. And then, and you have to pay attention to this next line, it adds 1 to num. That part is absolutely crucial. Without it, num would stay 1 forever. The condition would always be true and, well, that leads to a big problem. And that problem is something pretty scary in the coding world, the infinite loop. It's a classic rookie mistake. If you forget to write code that will eventually make your while condition false, your program gets stuck. It just runs the same code forever and ever, and your program will likely freeze. So remember, you have got to give your loop an exit strategy. Okay, so we've got our for loops for counting and our while loops for checking conditions, but what if you need more finesse? What if you need to change how a loop behaves while it's in the middle of running? For that, we have 2 more keywords, break and continue. Think about this. You're digging through a massive list, maybe 1 million songs, looking for your favorite one. You find it at song number 50. Are you really going to make the computer check the other 999,950 songs? No! You need a way to stop early, to say, found it, we're done here. And these are tools for the job. Break is like pulling the fire alarm. It stops everything. Right now, the second your code hits the break keyword, the loop is terminated, and the program jumps to the very next line of code after the loop. Continue is different. It's more like saying, not interested in this one, let's just skip to the next. It doesn't end the whole loop, it just ends the current iteration and jumps right back to the top for the next one. You see break used all the time when you're dealing with user input. You can set up a while loop that's designed to run forever, but inside it, you check for a specific word from the user, like quit or exit. As soon as they type that word, you hit the break statement and you're out. It's a really clean and common pattern. So let's zoom out for a second. Why does any of this matter? Why have we been talking about for loops and while loops and break and all these little details? Because this is it. This is the turning point. Mastering loops is what takes you from writing simple, one-off scripts to building truly powerful automated programs. Loops are the workhorses of programming. They're what lets you process thousands of files, add up numbers from a user, search through massive amounts of data, or just keep a program running. By using them, your code becomes shorter, cleaner, and a heck of a lot smarter. This is how you take a boring, manual process and turn it into an elegant, automated solution. So now you've got the tools. The power to automate is literally at your fingertips. So I'll leave you with this question. What's that one tedious thing you do all the time? That task on your computer you wish you could just make happen automatically? Go build a loop for it. Seriously, the best way to make this all stick is to pick a small, repetitive task and automate it. Go give it a shot.